A basic, simple diagram for that would be something like this. And I think the important thing here is that you've got a network firewall appliance, you've got your firewall running that's on an OS level, and you have a web application firewall. So you've really got 3 levels of defense before you even hit your web application. I think that's a key thing, and what I kind of want to emphasize over and over is you're going to, through a lot of this, you may see redundancy where we're basically defending against the same kinds of things 2 or 3 times. But the idea is if you screw something up in one place, hopefully you won't screw it up in the other place. You hope. Or if you miss something on one level, it can drop down, but you've got another line of defense before that. So mod security for Apache, that's a really, really good tool. And it's at the point where I feel that if you're running Apache, you're running... basically, I think that it's a requirement. It's not part of the standard Apache distribution as it is now, but I would not roll out an instance of Apache running without it. It's a very powerful open source web app firewall. There is commercial support for it, so you can, if you're working in a business or enterprise level and they want that, you can get those kinds of things. But like I described before, it basically intercepts, examines, and acts upon incoming and outgoing payloads. The data that, say, a web browser is sending to the server, and it's important that it can do both incoming and outgoing. We'll talk about that in just a sec. It also makes what they call chew routing, where you are restricting what the web server can do within the system, and changing things like the server signature, which we talked about before. It makes doing those things quite a bit easier. That's one of the nice advantages of mod security. It has a few different features like that, but primarily the interesting thing is its ability to filter and act upon certain things. So actually this might be misleading because I'm not sure that it actually does any sanitization. I should probably change that. But what it can do is, again, you're going to get input from some arbitrary client online, and it will come in to your web application. And Apache is going to the mod security in Apache is going to look at each of the different sets of information that you're getting and look at it. And it could be something as simple as just a regular expression. Look to say, okay, if the information we're getting contains this kind of a string that is indicative that this might be some kind of attack that they're sending, reject that, or log it, or do a number of actions on it. It's not on by default, but mod security can also do the same thing for output from the web server, so that if for some reason in one of these levels, whether in the web application firewall level or within the web application itself or what have you, if for some reason a malicious user gets your web application to spit out something bad back to a browser, it can cache it while it's going out. So it can examine that stuff and do the same kinds of things to it, either log or deny the request or what have you. So, kind of keeping Apache on a leash. The key things that I see for this are if you have dynamic code. That would be if you're writing something, say like in PHP, Perl, Python, that kind of thing. I really always recommend that, especially on what we call shared servers, that you do something that compartmentalizes it so that particular applications or particular, say, domains or things like that, you compartmentalize them so they're running under different user accounts on the system. The idea with that is it's sort of like on a ship where you have, you can, what do you call that, where you close off
batten down the hatches?
Yeah, you batten down the hatches, and it's compartmentalized so you can close off certain sections of the ship. So basically if one gets punctured and it starts flooding, if somebody has some bad code on their system and on your system and has a vulnerable web application, that can't be used as a way to get into the entire system and affect other users on there. and that kind of thing. It basically compartmentalizes it so the damage is restricted to what potential damage is restricted to what that user account can access, and obviously you set it up so it can only access what it needs to. So that's why it's particularly important on shared servers. If you ever have an opportunity to look at setups for most popular web hosting setups, they have maybe 100 users, 100 different accounts on, and 100 different virtual domains running on a particular machine. If you aren't doing something like SUEXECing it, or doing something where you're wrapping your CGI so that they're executing on a particular user and each one of those is executing on a different user, you have a real potential for one web application that's under one user's account to take out the whole system, and it becomes a real problem. So that basically, again, that kind of compartmentalizes stuff. The other thing is chi-rooting, jailing the Apache, is basically keeping the Apache processes, your web server processes, from accessing files outside of this jail sort of root. So if you have Apache set up to sit in a particular directory on your system, 2 or 3 levels down, you would set your root level at a certain point, and then the Apache process, which includes any of the dynamic stuff that it's doing, any dynamic code that people have written, PHP scripts, Perl scripts, Python scripts, Ruby scripts, things like that, they're not going to be able to go outside of that structure. So they're not going to be able to go up and say, oh, I want to go up and go into the etc directory and start mucking around and looking at configuration files and password files and stuff like that. And as I said before, mod security, or there's one that just is for this called mod chi-root is another module for Apache. Make this a lot easier. To do it by hand without these modules is much more difficult. It's possible, but it takes 2 or 3 pages to to write out how you do it, and it's a lot easier to do it this way. So we're going to talk about some kind of programming techniques here, where you're talking about web application development when you're actually writing the applications themselves in Perl or Python, what have you. The basic kind of idea here, and a basic sort of mantra for this, is that you filter everything coming in and you escape everything going out. And only when you are, well, I wouldn't even say that. I was going to say only when you're really sure do you not do that. But you have to be very careful of that and very aware of it. But and with this diagram, what it kind of shows is that you have a few different, the kinds of things that are coming in. You're going to have things that are coming in on a few different levels. On the get level, they call that in the HTTP protocol. The post level, cookies that are stored in the browser, and also file uploads, things like that. And the web application itself can spit out things, and these are the kinds of things that get spit back out from the web application that can do nasty things to the client or trick the client into doing things that are not good. It's going to be able to send things like HTML and CSS. Those kinds of things are generally not too worrisome. But JavaScript that gets executed by the client is potentially very problematic. Especially, typically JavaScript has access to your cookie information, can take that, can read that stuff, and then say pass that information on to another server, things like that. Plugin content is a problematic thing. That was, I don't know, was it a month and a half ago, where there a hole that was in Flash version 8 was exploited on, well, there's actually been a couple things on MySpace, but a recent one was a banner ad that was put into rotation on MySpace, a Flash banner ad,